Hello guys, welcome back to my channel. In today's lesson, we are going to learn on how to convert binary to hexadecimal numbers. And before we dive to the actual thing, we need to have some little basics about the binary. And a binary is a 2 digits number that is 0 and 1. That's why it's known as bi means 2. So binary is a 2 digit number, that is 0 and the 1. While for the hexadecimal, this is a combination of the decimal with the other letters. And if you can still remember, for the case of decimal, this part, decimal, it's a Latin word which means 10th, deci, and it's a number system which runs from 0 all the way to 9. As you can see, the numbers run from 0 to 9. While the other part, we have the letters to represent the other remaining numbers to total to 16. So we have A all the way to F, and each has its equivalent value. For 0, this is the binary value, while for the F, this is the binary value. Okay, these are the steps that you take whenever you want to convert a binary to an hexadecimal number. It's a very simple step. As long as you follow it, you will get your answer correct. So number 1, you write down the number, then you arrange the bits in a group of 4. Just as you can see, the binaries are in groups of 4. Then step number 3, you compute the decimal equivalent of each group. Then number 4, you combine the decimal number, and lastly, you write your answer in a base 16, because if you count the number of hexadecimal, sorry on this, supposed to be hexadecimal, they are 16 in number. Okay, let's move to an actual example so that you can try to compute. So we have this number, example 1, we have 11011011101 base 2. So this is a binary number. So we need now to convert this one into an hexadecimal number. So remember the rule. Number 1, you need to arrange your number in a group of 4. And as usual, this is very important for you to note, is that when you are trying to convert a binary number to an hexadecimal number, you are supposed to arrange from the least significant number. That is 4 for the integral part. While for the fractional, you are supposed to start for the fractional, it's supposed to be, for this one, it's supposed to be for, if the bits are less than, but maybe I will come to that later on. But for this one, let's arrange in a group of 4. So we have the first bunch. Maybe we can give this a different color. Then we have this one, another group, another color there, and lastly we have this one. Okay, give it a different color. So what we have done, we have arranged the work in a group of 4. So group number 1, we have 1101. Okay, then 2, we have 10, 10. Then we have 11, 0, 1. So step number 1, as usual, is to write down the number in a group of 4, which we have already done that. Okay, the next step is to get its decimal equivalent. If you look at the table that you had, let me see whether it's possible to get the other number. Okay, let's try to get this one. Let me see whether it's possible to see the number. Okay, so what we have the value for 1101. So we check from the table 1101, 11, where is 11? This one. 11 is equivalent to 13. This is 13. And 13 for the decimal number, we have decimal equivalent, but for the hexadecimal, this one. This one it's equivalent to D. Maybe you can count. We have 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. Supposed to be. It's supposed to be. It's supposed to give us the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then 13. So it's supposed to give us the letter D. Well, for the 1010, where is the 1010? This is the 1010. If you look at the hexadecimal to binary, it's supposed to give us a value of A. So this one is supposed to be A. A is equivalent to 10, while 11 is 11, 1101 is supposed to give us a value of 13, the decimal, which is equivalent to D. So we have already now the solution for the whole thing. So we have 1 is equal to D, 10 is to A, 11 is to D. Now after that, the next step is to write the answer, which is supposed to be D, D, then the base 16. Supposed to give us the base 16. So we have is supposed to be base. So that is now the answer. So this one, the binary 1101, 10, 10, 1101 is equivalent to DAD16, which is our hexadecimal. And don't forget that whenever you are writing your answer in hexadecimal form, you must include the base 16 because that's now the value for it. Okay, let's move to the next part. The next example, we have this one. As you can see, we have integral parts on this side and the fractional part on the other side. So number one, you have to confirm whether you can get a group of 3. And as you can see, it is not totaling to a group of 4. So so you need to note this one. If the bits are less than 4, then you are supposed to add 0 to the left of the bits, of the integral part. So this is our integral part. So you're supposed to add other bits for it to total to 4. While on the other side, on the right of the bits for the fractional part, to make it to be 4 bits. So if you look at this one, we have the first group. Okay, let me do that. Then another group, it's missing. It also have an extra 0. So you are supposed to add 3 to total to 4. I hope up to that point we have together. If the bits are not totaling to 4, you need to work and add. Okay, let me do this. Okay, for the yellow part, as you can see, this is our integral part. You are supposed to add towards the left. But for the fractional part, you are supposed to add towards the right hand side. I hope up to that point we are together. Okay, having that done that, the next step is to write down the numbers. Then these one, I'm trying to to paste. Then here we have the point. Then these one. Okay, having done that, let me do this. Okay, the next step is to get the decimal equivalent. The decimal equivalent for 000 is actually 0, and this is equivalent to 0, and almost 0. Then we have this one 111. As you can see, let me try to get the other table. So we have a 111 11. This is our 11. 11 is equivalent to 15. So this is equivalent to 15, and 15 is equivalent to this. As you can see from my table, this is 111 is equivalent to F. Then this one we have the 000, which is as usual supposed to give us 0, and the 0 is 000. So this is 0, which should give us also the 0. Okay, having done that, the next step is now to write the answer, and our answer is supposed to be, let me do this. The answer is supposed to be 0 point. Don't forget the point. This is the point where we have the point. That's where we have our point. Then we have F and 0. Then we give to the base. Remember the rules for the base. The base is supposed to be base 16. Base 16, just like that. So those are the rules that we follow. What you should have noted by now is that when you are working with a number with less than 4 bits and you want to convert it from binary to hexadecimal, for the fractional part, you had the zeros on the right side, while on the integral parts, you had zeros on the left side. So that's the most important part for this one. Up to that point, we had together. So you can use the example that we have to navigate through this particular concept. Now for your exercise, you can try to practice with this one. You group it in a group of 4, and if they are not enough, try to add another 0, factoring in the factors that, or the rule that I've already highlighted to you. And you should get this is the answer to confirm whether you have done the right thing. This should be your answer. Maybe I might give you time to go through, so which is AC dot E16. That's our answer. 16. This is our 16. E16. So I'll give you maybe some few minutes to go through your work, then I will do it. So there goes my working. Maybe you can use this table to do the conversion. So I hope by now you are through with the working. So if you are not sure or you are still having challenge on how to go about it, you can check my next video. So thank you for taking time to watch. Don't forget to subscribe, and if you have any question regarding the conversion, kindly write it down on the comment section. I will get back to you, and I know and I believe that I will be able to help you to get this particular concept. Thank you. Don't forget to subscribe. Bye bye.